Welcome back to our discussion about the attributes and analysis of graphs of functions. And in this video, we're going to really focus in on describing what is happening in graphs. We're going to focus on how do we identify intervals of increase and decrease, and how do we identify what are relative maxima and minima and where do they happen. So let's go ahead and jump in. So let's look at this graph and determine the areas on this graph or the intervals where this function is increasing or decreasing or remaining constant. So one of the easiest things you can do is think about if you were to trace this graph from left to right. Okay, if you are tracing this graph from left to right, any areas where your pencil is moving upward on the graph are areas where the graph is increasing. Okay, so I'm going to shade those in yellow. Okay, do you see that those yellow areas the graph is increasing on? Increasing, all right? And then anywhere where the graph is going down as you trace from left to right, that is where the graph is decreasing. And I'm going to shade these in green. Okay, notice over here we're decreasing, we're going down, and here we're decreasing. Okay, awesome. So now we want to think about, well, how do I communicate this? I can see this on the graph, but I want to be able to communicate what is going on. Now notice that we are going to describe where the function is increasing by listing the interval of the x values. Whenever you see the word where, we're talking about x values. So we are going to think about where is the function increasing, and we're just looking at the x values in yellow. So that would be the interval from -2 to 0 and from 3 to 5. Those would be the intervals where the function is increasing. And this function would be decreasing by looking at the intervals in green on the x-axis. So this is decreasing from -3 to -2 and also from 0 to 3. So you can just really focus on the x-axis here and the parts of it that are shaded green or yellow. Now, one of the most common misconceptions here for students is that they think that they want to indicate how far down or up the graph goes, and that's not what we're communicating at all. We are just communicating where is the graph increasing, where is it decreasing, and that is always going to refer to your x values. Now, another thing I want you to notice is that these intervals are always open intervals. Notice that even though this is a closed circle, we are not going to close that off as a closed interval. Actually right here, right? And that's because at that point, it's where it begins to decrease, right? And that point of change right here is not where it's increasing or decreasing, but it's a point of change, so it's not doing either one. Okay, so you're never going to include endpoints in your intervals of increase and decrease. Let me say that again. You are never going to include endpoints in your intervals of increase and decrease. Okay, they're always going to be open intervals. Let's talk about what are relative extrema. Okay, relative extrema are relative maxes and mins. Okay, and a relative max is a point that occurs where the graph changes from increasing to decreasing. So let's just think about this as something that's increasing and then decreasing, right? So you're thinking about like the peak of a hill. And if you look at this graph over here, you can see where the yellow part is increasing and the green part is decreasing. We have a relative max right there. Okay, and there are two kinds of things that we are going to talk about with a relative max. We're going to talk about what is the max and where does it happen. And one of the analogies I like to use here is it's the same thing kind of as saying where is the highest mountain peak in the United States and what is the elevation of the highest mountain peak in the United States? These are two different questions with two different answers, and so we need to look at what the question is that's being asked. Okay, so when we're describing where there's a relative max, remember where is referring to an x coordinate. All right, so where does it happen? That happens at x equals 0. See, x equals 0 is where the relative max happens. And then what is the relative max? Well, that is going to be the actual y value. How high does the function get at that point before it starts decreasing again? And that is going to be -2. There's a relative maximum of -2 on this graph. Okay, so now let's think about relative minimum or relative minima. Okay, and minima is just plural for minimum. Okay, so a relative minimum will occur when the graph changes from decreasing to increasing. Okay, so similarly, we're going down and then we're coming up. So we're looking at the very lowest part of a valley when we're looking at graphs here. Okay, so in this case, we have two relative minima. Okay, one's going to occur right here where it changes from decreasing to increasing, and another is going to happen right here. Okay, so here we go. We've got two relative mins. Now, where do those relative minima occur? Remember, where is going to refer to the x values, the x coordinates. So we have relative minima occurring at x equals -2 and x equals 3. Now, what are the relative mins? That will refer to the y coordinates at those corresponding x values. So we can say there's a relative min of -3 and there's a relative min of -5. Now, in this discussion, we're not talking at all about global maxes or global min, or sometimes we call them absolute maxes or absolute mins. We're talking about relative maxes and mins, and that is always a change from increasing to decreasing. So that wraps up this video, and in our next video, we're going to talk about what makes a function even or odd. And I will see you then.